Okay, so first question for checkpoint 19 says that an experiment consists of rolling a dice, then flipping a coin, and the following tree diagram shows all the possible outcomes. We want to know what is the probability of rolling a 6 or landing on tails. So for this problem here, I can either roll a 6 or I can land on a tail. So whenever you see the word or, that means at least one of those has to happen. Okay, so I can either land on a 6 and I'll be good, or I could not land on a 6, but if I land on tails, then I'm good. Okay, so with or, one or the other event must happen. So if I roll a 1, but then flip tails, that counts, right? Because I'm flipping that tail. So even though I didn't roll a 6 first, I still flip my tail, so I'm still good. If I were to roll a 2 and flip my tail, still good, right? Because I'm still landing on tails. Same thing with 3, same thing with 4, and then same thing with 5. Now, if I were to roll a 6, right, if I roll a 6 first, I'm automatically in the clear because that was the first condition I had, right? Rolling a 6. So even if I roll a heads afterwards, that's okay because I've rolled my 6. And if I roll a 6 and flip tails, then that's even better because that's doing both. But I don't necessarily have to. I just need to have at least one or the other. So what I'm highlighting here are all the possible outcomes that work for the probability question that we're being asked, right? I need to either roll a number 6 or land on tails. So out of all of those options, okay, no problem, Natalie. Thanks for popping in though. So out of all of these possible options, right, how many do I have highlighted? I have 7 highlighted, right? So I would have 7 different outcomes where I'm either rolling a 6 or I'm landing on tails. And how many total options do I have to pick from here? Remember, to figure out your total, you can count how many heads and tails we have in the very last column. So if I were to go down the very last column, which is the coin one, and count how many heads and tails are there, how many would we have? So I'm just counting all the number of tails and heads. 12, thank you. Yep. So that means I would have a 7 out of 12 chance of rolling a 6 or landing on tails. And 7 over 12 I can't simplify, so that would just be my answer, 7 over 12. So I'll give you guys a second to type that in and then let me know when you guys are all ready to go on to the next one. Perfect. Junior, are you ready as well? All right. So here's our second one. Second question. I'll give you guys a second to find this one. So on this problem, look for the tree diagram that has the 2/3 and 1/3 on it. And then the question is, what answers are possible outcomes for Natalie's work outfit? So this one's, I believe there's more than one question that has this tree diagram, so make sure you're paying attention to the question after it. So which answers are possible outcomes for Natalie's work outfit? All right, Naira's there. All right, hopefully we're all at this problem. So pretty much what we need to do here is read through all of the different answer choices and look at our tree diagram to see if it's possible, right? So the first option says she can wear a blouse with pants and sneakers. So here she could wear a blouse, she could wear it with pants. However, does she have an option for sneakers? She can either wear sandals or boots. So can she wear sneakers? Nope, right? She doesn't have sneakers as a choice. So this first one we don't want to pick. The second one says a tank top. Well, if I look at my options or the options that she has for her shirt, she can either wear a sweater or a blouse, right? Neither of those are tank tops. So this tank top option would also not be one we want to choose. The third one says that she can wear a blouse with a skirt and boots. So that third one has three options, all from our tree diagram. So this third one is one that I'd want to pick. The fourth one on this one says that she could wear a sweater with a skirt and then sandals. Does that one work based off our tree diagram? So a sweater with a skirt and sandals. Yep, right, because I have all three of those options on my tree diagram, so this fourth one would also work. And then the last one says a sweater with a skirt and a blouse. So if I were to start with a sweater and then go to skirt, I can't go like this to blouse, right? Because there's nothing that's connecting this skirt to this blouse. And she's also not wearing shoes here. So this isn't really an outfit if she's not wearing shoes with it. So this very bottom one, we also would not want to pick. So there are two right options for this question. We'd want to wear a blouse with a skirt and boots or a sweater with a skirt and sandals. And then let me know when you guys are ready to go on to the next one. Naira, are you ready as well? Perfect. Okay. So next question we have here, we want to know, whoops, what is the probability of selecting a spade and flipping a tail? So what's the probability of selecting a spade and flipping a tail? We have this tree diagram that has the different suits and then heads and tails. Perfect. Tristan's got it. And again, for this one, make sure that the question, that you double check the question, because there's more than one problem on here that will use the same tree diagram. So just double check it. Perfect. Okay. So I know Dawson will be right back, but let's start going over this. So it says, what's the probability of selecting a spade and flipping a tail? So because this question has this word and in between our two events, that means both of those events have to happen in order for it to count. So I have to select a spade and flip a tail. So if I look at my tree diagram, here's spade, right? So if I pick a spade and then I pick a tail, do you guys see any other times where that could happen again? Based off this tree diagram, is there any other times where this could happen again? Nope, I don't see any other ones, right? It's just that one time. So the probability of me picking a spade and then flipping a tail would be 1 out of. And then how many total outcomes do I have here? Again, to figure out your total, you count how many heads and tails are in this coin branch. So I'd have like 1, 2, 3, 4, 5, 6, 7, 8. Right, perfect. So the probability, of me picking a spade and flipping a tail would be 1/8. So 1/8 for that probability. All right. Number 4, can't find it. Maybe double check. Did you just get it? No. We can skip it, Naira, and then remind me at the end to go back to it, because by then hopefully we'll be able to figure out which one we didn't see yet. If you can't find it still. You found it? Perfect. It's okay, you're fine. There's 15 questions you have to click through, so it's okay if it takes you a second. All right, so while Naira's writing in the answer for that last one, the next question we have is a multiple choice question. And it is asking us which tree diagram shows the possible sandwiches that have 1 bread, 1 meat, and 1 cheese. Dawson, do you have a question? Okay. So we're looking for tree diagrams. We want to know which tree diagram correctly shows possible sandwiches that have 1 bread, 1 meat, and 1 cheese. Okay. So this question says that there are 2 different options. We could have white bread or a sourdough bread. And then there are 3 different options for meat, which are ham, turkey, or roast beef. And then for cheese, we can either choose provolone or cheddar. So we just want to know which tree diagram is basically correct from what the question is giving us, right? So the first set of branches we should have is our bread, and we can either have white or sourdough. So our tree diagram should start out looking something like this. W for white bread, not an H. I should have an S for sourdough. Okay, so if I look through these answer choices, all of them start like that, so that's good. Next, I have 3 different options for meat, which are ham, turkey, or roast beef. So if I were to pick white bread, I could have ham, turkey, or roast beef, right? What 3 branches should I put underneath the sourdough? If I pick sourdough bread, what are the different options I could have for meat there as well? I could have the same 3, right? I can still pick ham, turkey, or roast beef. Perfect. So now looking at this tree diagram, this one down here where I only have 2 options for meat based off of whatever bread I choose, this one is not correct because it's not listing all 3. So this bottom one is not one we want to pick. Now, when I go and list my cheeses, I could have either cheddar or provolone, right? So if I pick a sandwich with white bread, ham, I could have cheddar or provolone. Even if I pick turkey, I could have provolone or cheddar. Same thing with roast beef, provolone or cheddar. Now, on the right side of our tree diagram, I'm going to have the same options for cheese. Right? So what we need to do is just go through our tree diagram and figure out which one is correct. So which one looks like this tree diagram we have here. Now there are 2 that look very similar, but be careful on this choice where it says cheeses, it's giving me turkey, roast beef, ham, roast beef. Right? Those aren't cheeses, those are meats. So we want to make sure that we are picking the right tree diagram, one that has the meat in the meat section, the cheese in the cheese section, and bread in the bread section. So we'd want to pick this one here. And then let me know when you guys are ready. Think you got it? If you accidentally select the wrong one afterwards, just let me know and I can give you another attempt so you can fix that one. Nayara, are you ready as well? Perfect. All right, next one has that sweater with a blouse, the 2/3 and 1/3 tree diagram as well, except this question is asking us probability. So we want to know what is the probability of randomly selecting an outfit that includes a blouse, skirt, and sandals. So what is the probability of selecting an outfit that includes a blouse, skirt, and sandals? Perfect. Dawson's good. Perfect. Junior, do you also see this one as well? Perfect. Okay. So on probability problems where they're asking you to find probability, whenever you see the word and tells you that you are multiplying. Okay, so since this problem says a blouse, skirt, and sandals, what we need to do is multiply all of our probabilities together. So if I look at the section that is talking about tops, right, she can either choose a sweater or a blouse. So if she has 2 options and only one of them is a blouse, what is the probability of her picking a blouse, right? Only looking at the section of dealing with tops. Right, she has 2 total options, and how many of them are a blouse? 1, right? So she has a 1/2 chance of picking a blouse, okay? Because she can either pick a sweater or blouse. Only one of them is a blouse. Next, let's look at probability of bottoms. So the question here is asking us for a skirt right? Now, the reason why there's these probabilities in front of pants and skirt is because that is telling us the probability of her picking pants and her picking a skirt. So this 2/3 tells me that she actually has 2 pairs of pants, and 1/3 is telling me that she has 1 skirt. So that means she technically has 3 different options for bottoms. 2 of them are pants and 1 of them is a skirt. So instead of having 3 branches that say pants, pants, skirt, they kind of shrunk it and made it not as like long as it normally would be. So since the question is asking us for the probability of a skirt, what fraction is in front of skirt? The 1/3, which means she has a 1 out of 3 chance of picking a skirt. Okay, so if you have a problem like this on the exam, make sure that you are looking at it carefully. Okay, so if there's a fraction in front, that's the fraction for whatever outcome it's giving you. Are there questions on how we got that 1/3 for the skirt, or are we okay? Dawson, what's your question? I'm not, no, not currently. So the reason why it's 1/3 is because, so let me erase this. Oops. So if you look at the tree diagram, do you see how there's this 2/3 and then 1/3 on the branches in front of pants and skirts? What this is saying is that there's 3 total options for bottoms, right? Because 3 is in the denominator for both. It's it's kind of like it should look like this. It should have pants, pants, and a skirt. But what they did was they kind of shrunk it and simplified it since she has 2 separate options for pants. So they took those 2 pants and made it just 1 branch, but because she has 2 different options, that's why there's that 2/3 in front. And then we have a 1/3 for the skirt. So that's why. So when you're looking at tree diagrams, be careful because there's probably going to be one like this on your exam. So don't let it trick you. So if you see a probability on a branch, that's the probability of picking that option. Does that help clarify? Okay. I'm assuming, I think we have one other question that is like this. So we should see this again. And if not, I can come up with an example later for us to go over. All right, so the last option that she has is shoes, right? And she wants to pick sandals. So she has 2 different options, sandals or boots. So what would be the probability of her picking sandals? She has 2 options and one of them is a sandal. So Dawson, that 2/3 and 1/3 only count for bottoms. So the fraction only goes with the outcome that's directly after it. It's like they're a pair. Since on the shoes section, there's no fractions on our branches right here and right here, that means that for shoes, there's just those two options. So that those fractions, this 2/3 and the 1/3, only go with pants and skirt. But since on the next branches for the shoes, she just has those two options, right? And there's no fractions on the branches. That means that probability of picking sandals would just be 1/2 exactly. Yep, because she has two options and one of them is sandals. All right. Is everyone still with me? All right, perfect. So now all that we have to do is multiply our probabilities together, because since we have the word and in our problem, that tells us that we are multiplying. So when you multiply fractions, you multiply straight across the top, straight across the bottom, right? So 1 times 1 times 10, just give us 1. And 2 times 3 is 6. 6 times 2 is 12. So here she would have a 1 out of 12 chance of picking an outfit that includes a blouse, a skirt, and sandals. So a 1 out of 12 chance. Anytime you guys see a tree diagram that has fractions on the branches, like this one does here, I would not use the tree diagram, like kind of outlining the paths to find the probability, because notice how she has a total of 12 options, but in our last branch, you count only 8. If you have one that has probabilities, I would recommend doing it this way, where we just find the probability of each different option, like so one for top, one for bottom, one for shoes, and then multiplying it together. All right. Next question has a tree diagram that shows card color and dice rolling. And we want to know what are the possible outcomes for the experiments. We're just selecting all that apply. So 3 times 2 is 6 and 6 times 2 is 12. Perfect. Yep. Which is why we have a 1 out of 12 chance. All right. And then I'll give you guys a second to find this problem and let me know when you are ready. Perfect. Perfect. Awesome. Okay. So we want to select all the different outcomes that are available based off of this tree diagram here. Now, this is the one where make sure that you're double checking it, because they put one in here to trick you. And if you're not looking at it carefully, you might accidentally select it. Yeah, Dawson found it. So if I look at the first one, B6, I could pick a black card and roll a 6, so that one works. The next option is red black, but that one does not work because there's no branch that's connecting these two, right? I should be picking a card and then rolling a dice. So that the second one would not work. If I were to pick a red card and then roll a 3, that one's good. 5 and 6. 5 and 6 won't work because I need to pick a card first and then roll my dice. R2 would also work, right? I could roll or pick a red and then roll a 2. And then the very bottom one is S2. So there's no cards that I know of that are an S color. I don't even know what color that would be. So this bottom one also does not work. So there are 3 correct answers here. We want B6, R3, and R2. So those are the 3 ones that we want to pick. Oh yeah, it could be the type of, it could be spades, yeah. But even then, that's still, we're talking about color suit. But yes, it could be spades. Hi, Tyler. So Tyler, right now we're going over checkpoint 19. Is that what you wanted some help with? All right, next question, guys, use the same exact tree diagram. This question is, what is the probability of selecting a red card and rolling that is less than 3? So what probability of selecting and a number that is less than 3? All right, and then Naira and Junior, let me know when you find it as well. Perfect. Okay. So we're asked, what is the probability of selecting a red card and rolling a number that is less than 3? So immediately we're looking at red cards, right? Because that's what the question is asking us. And we need to roll the number that is less than 3. So what numbers could I roll that are less than 3? What different numbers are less than 3? I could roll a 1 or a 2, right? Rolling a 1 or a 2, both of those are less than 3. Is 3 less than 3? No, right? 3 is equal to 3. So we're not including 3 for this problem. Now, remember, since it has that word and in between, that means we need to have both of those events. I need to have a black card and I need to roll less than 3. So that means that I only have 2 possible outcomes that fit our probability question. So I would have a 2 in the numerator. And how many total outcomes do I have here? If I count all of the numbers in my dice branch, how many possible outcomes, or how many total outcomes do I have? I should have 12, right? I have 6 here, and then I have another 6 on the bottom. So if I have a 2 out of 12 chance, that simplifies to what fraction? 1 over 6, perfect. So I have a 1 out of 6 chance of picking a red card and rolling a number that is less than 3. So a 1 out of 6 chance. Next question is going to use the tree diagram that has the card suits, so like heart, diamond, and club, and the coin, head, and tails. The question that we're being asked is, what are the possible outcomes of the experiment? So what are the possible outcomes of the experiment? Kristen's got it. Aaron's good. Dawson's ready. Oh, it looks like Junior might have accidentally left. Maybe he'll pop back in. Okay. So based off of this tree diagram that we have here, right, what would be possible outcomes that we could have based off this tree diagram here? Remember, we need to have a card suit and we need to have a coin flip in our possible outcomes. Or I guess if typing it takes you guys too long, how many correct options do you see here? So how many correct options do you see? So Dawson sees 3, Tristan sees 3. Junior, the tree diagram for this question is the card suit and then head or tails. And the question is, what are the possible outcomes for this experiment? I agree with Tristan and Dawson. I also see 3. So I see these two, the club and tail, and spade and hearts. And then there's also this heart and tail down here. So those would be the 3 that you'd want to pick for this problem. So we would want to pick club and tail, spade and heart and tail. Oh, whoops, you're right. Not spade and heart. I was looking at heart and I saw heads because it started the same way. We want to pick heart and head. There we go. It's tricky on my eyes. Heart and head are spelled so similarly. Thank you. So those are the 3 we'd want to pick. Club and tail, heart and head, and then heart and tail. So Naira and Junior, let me know when you guys are finished selecting your answers. Perfect. All right. Next question. So again, this is a multiple choice tree diagram question. And it's talking about Martha. It's saying that she has 2 polos and 3 t-shirts, 1 pair of pants and 1 skirt, and then 1 pair each of sneakers, boots, and sandals. Yeah, this one is, this one's probably the trickiest tree diagram problem we've done so far. So let me know when you guys are here and then I'll start going through it. It's not that bad as long as you know what's happening. Naira, were you able to find this as well? Okay. So notice how, so she has 1 pair of pants and 1 skirt. Okay. If I look at this tree diagram, she has 1 pair of pants and 1 skirt. That's good. Then it says she has one pair of each, sandals, sneakers, and boots. So this very last column with the 3 different options is also good because she has one of each of those types of shoes. However, if you read the very first sentence, it says that she has 3 polos and 2 polos and 3 t-shirts, right? But if you look at the first row or column of our tree diagram, she only has this polo and this tee, right? Which means that we need to determine the probabilities to put on those branches that represent the amount of polos she has and represents the amount of t-shirts that she has. So if she has 2 polos and 3 t-shirts, right? How many total shirts does she have to pick from? 5, right? Perfect. So she has 5 total shirts she can pick from. Out of those 5, how many are polos? 2. And out of those 5, how many are t-shirts? Perfect. So that means that she has a 2 out of 5 chance of picking a polo and a 3 out of 5 chance for picking a t-shirt. Now, if I look through these 3 options it gives me, I have decimals, right? So not fractions, but decimals. So what I would do here, if you're not 100% positive what 2 polo or 2 over 5 is as a fraction converted to a decimal, I would type it into a calculator just to double check, right? So 2 over 5 is 0.4 and 3 over 5 is 0.6. So when I'm looking at my tree diagram, I want to pick the tree diagram that has a 0.4 for polo and a 0.6 for t-shirts. Because for polos here, she has a 0.4 chance, and for t-shirts, she has a 0.6 chance. So Dawson, does this make sense as to why we're putting those numbers on those branches? Perfect. Okay. So again, we want to pick the 0.4 and the 0.6 option here. All right, next question has us rolling a dice and then flipping a coin. The question is, what are the possible outcomes of this experiment? So another question where we're asked, what are possible outcomes? So for this one, we're rolling a dice and flipping a coin. And then once you're there, look through the answer choices and tell me how many correct answers do you see? Dawson, what's your question? The last one should have, you want to pick the tree diagram that has a 0.4 and a 0.6. Perfect. Let's see. So Tristan sees 4 and Naira sees 3. Junior, how many correct possible outcomes do you see here? And Dawson, same with you. Junior sees 4. All right. So the first one I see is this 6T, right? 6T is down here. I can roll a 6 and then flip a tails. The next one I see that works would be 1T. I could roll a 1 and flip a tails. 6H also works, right? Because I could roll a 6 and flip heads. And then this very bottom one also works, 3 and T. I could roll a 3 and flip a tails. So Naira, do you see the one that you might have accidentally skipped or missed when you looked the first time? It's okay, you're fine. That happens sometimes. All right, so we should have these 4 answers, 6T, 1T, 6H, and 3T. Next question. So the next question is using that tree diagram that, didn't we answer one that's just like this? Oh, this is the one. There's 2 of this question. I remember now when I was looking through the checkpoint. There's 2 of this same exact question. So it's the one that has Natalie's outfit. Me want to know outcomes. So you should have 2 of these. And the answers are going to be the same because it's the same exact answers. It should be a blouse with a skirt and boots. A sweater with a skirt and boots. A blouse with pants and sandals would also work. Right? Guys, double check with me. So for this one, there's actually 3. I think on the other one, there might have only been 2. But it's weird because it's the same question. But this one has 3 different options that work. So a blouse with pants and sandals, a sweater with skirt and boots, and then a blouse with a skirt and boots. Let me know when you guys are ready and we can go on to the next one. Yeah, I don't know why they put 2. It might have been a mistake when they were making the checkpoint. All right, next question uses the same exact tree diagram, except here we're asked for probability again. So we want to know what is the probability of randomly selecting an outfit that is a sweater, pants, and boots. Oops, that's not an eraser. So sweater, pants, and boots. So again, this question uses the word and in between all of our different events. This one is very close but slightly different. So on this one, we're talking about pants. On the other one, we used a skirt. So very close, but just the one event that's different. So because we're using the word and in our probability question, that means we're going to multiply our probabilities, right? So if we start with the very first column, looking at tops, if I need to know what's the probability of her picking a sweater, right? She can either pick a sweater or a blouse. So what would be the probability of her picking that sweater? 1/2. Perfect. Yes. And then let's look at bottoms. Remember that the fraction that's in front of our outcome is the probability of picking that. So if she wants to wear pants, right, if I'm looking at pants here, what fraction is on the branch that's in front of my pants? 2/3, which means that she has a 2 out of 3 chance of picking pants. And then let's look at the very last one, which is shoes, and she wants to wear boots. So she can either pick sandals or boots. What's the probability of her picking boots? She has two different options. This one would also be 1/2. Perfect. Now again, because the word and, we're going to multiply. So 1 times 2 times 1, give me 2, right? 2 times 3 times 2 would give me 12. So if my probability here is 2 over 12, that can simplify to 1 over 6. Perfect. Yes. Oops, sorry. So this means that she has a 1 out of 6 chance of picking an outfit that has a sweater, pants, and boots. So 1 out of 6 chance. You get it now? Awesome. Perfect. All right, let me know when you guys are ready and we can do the next one. We're almost done. Alrighty, so the next one has these weird looking, I guess I shouldn't say they're weird, but it's not your typical tree diagram. They're the circle ones. And it's asking about an experiment that consists of drawing a card from a deck, recording the suit, and then rolling a dice to get even or odd. What is that? There's still tree diagrams, except instead of it starting on one side like this one did, it starts in the center. So the center is like the starting point. That's what circle tree diagrams look like. A lot of the times people use these ones to show outcomes where you have a lot of stuff going on. Like our first branch has 4 options, right? So if sometimes it's easier to branch it out from the center than it is the other way, but it's the same, just slightly different. So if the first thing we're doing is drawing a card and recording its suit, right? There's 4 different suits that you could pick from when you are picking a card, right? You could land on hearts, you could land on spades, clubs, or diamonds, right? So for this one, our tree diagram is starting in the center. And these are the 4 different options that we have, right? Then it says we're going to roll a dice and record whether it's an even or an odd number. So if I were to pick heads, I could then roll an even or an odd number. What happens if I were to pick a spade first? If I were to pick a spade, what would be my branches that are coming off of this S? Even or odd, right? So I would have 2 branches again, even or odd. What about if I were to draw a club first? So this very bottom one here. If I were to draw a club first, what would be the branches that come off of my club? The same, even or odd, right? And then same thing with diamond. I'm doing the same exact thing, but so every single branch in the center should have the same branches outside. So we want to pick the tree diagram that looks like this one down here, where we have our 4 different suits. And then on each of those suits, we have an even or an odd number that is being rolled. Dawson, doing it from the start, right? So like drawing it from start, does that help you see which answer is correct? From left to right. So, I mean, when you're asked questions like this one that have these circle tree diagrams, if it helps you, you can look. So if I were to look at the very last event that's happening in this problem, it says that we're rolling a dice and recording whether it's even or odd, right? So that means on my very outer branch, if I'm looking at my outer branch, I should have two options on each one. I should either have an E or an O for even or odd. So if I look at this first one, I only have one. So this first one can't work because right here, I'm missing my even branch. If I look at this one here, I have an extra one. I have an even and odd, but then I have this H. So this one also can't work. But this very bottom one here, I have my even and odd. So this bottom one works, and I can tell just by looking at my outer branches, right? I have even and odd. So if it helps, usually the last branch is where they will make their mistake. And if they didn't make their mistake on their outer branch, look at the first one. Does that kind of help a little bit with the circle ones? Kinda. It's just practice and looking at them to see, just getting familiar with it. If you were to take this problem and write it out where it's not in a circle, so you have your four options like this, so hearts, clubs, diamonds, spades, and then have your even or odd on all of these. Right? If you were to write it like this, can you take this tree diagram and kind of take it and like wrap it in a circle in your brain to get this one here? Maybe. You could also write it normally and then look at your very bottom row. And in the very bottom row, I have nothing but E's and O's, right? Which means that when I look at the very outer edge of my tree diagram, I should also only have E and O's, and I should have the same amount. So if I have 8 here, I should have 8 on the outside here as well. It's way easier than the circle. Yeah, so if you need to do it this way first, that's fine. And then count how many you have in the outside and double check it out here. And then if that's the same, double check what it's labeled as. So just kind of cross check everything. Hopefully that'll help a little bit. For circle ones, it should be 2. I don't think there's any on your exam that have 3. For like any. I'm not 100% sure. I know, well, think about like the example we did with Natalie's outfits. That one has 3 different rows of branches. So it just kind of depends. But that one wasn't in a circle. That was a normal one. So the circle ones, I believe, should always only have 2. All right. 2 more questions. So this next question wants to know what needs to be done to complete the tree diagram. And it says that we are drawing a card, recording the suit, and then rolling a dice and recording whether it is even or odd. And here is our tree diagram. So we're picking a card, then rolling a dice, recording whether it is even or odd. So when you guys find this problem and you're looking at the tree diagram, what do you think is missing from it? Knowing that we're picking a card, writing down the suit, and then looking to see if we roll an even or an odd number. So what do you think is missing? Jocelyn says spades is missing. Spades is missing. Perfect. So if spades is missing, do we also need to add the even and odd branches attached to it? Yes, right? Perfect. So we need to add a spade card column, and we need to add the even and odd branches to that. Junior, do you have questions on this one, or were you able to find it? Good? Okay. Alrighty, and then very last problem. Let's see what we get. All right, we have another tree diagram one. So here we have an experiment that consists of drawing a card and recording the color. And then we're going to roll a dice and record its value. So when we pick a card from a deck and pay attention to the color, we can either have red or black. Whoops, right? So red or black are the color options. And then if I'm rolling a dice and I'm recording the number that pops up, what are the options I could roll on a dice? So what different numbers could I roll from a dice? What is the first one? It's a not correct tree diagram. The last one was picking a spade and adding even or odd. So the last one was picking spade and then rolling even or odd. All right. So Tristan says I could roll a 1 through 6 when I'm rolling my dice. He is correct. So if I start, I can either pick a black card or a red card. And then when I roll my dice, I can roll a 1, 2, 3, 4, 5, or 6. Right? But even if I were to pick a red card, I could still roll a 1, 2, 3, 4, 5, or 6. Right? So when I look through the tree diagrams, I'm looking for an option that has a red and a black card and also has a 1 through 6 attached to each color. So this center one, well, it might not be the center for you, but this one here that looks a little bit different than my tree diagram, but still has all the same outcomes attached to the right colors, where I want the black to have 1 through 6 and the red to have 1 through 6. So that would be the correct answer for this very last one. And that's it. That is checkpoint 19. When you guys have chose that answer, feel free to submit it and make sure that you get 100. Awesome.